So, you want to go to space? What's a rocket anyway? Hello, science fans. Have you ever looked up at the moon or the stars and thought, wow, I'd love to go there? Well, getting there is a big, big job. You can't just take a car or a plane. The sky goes up, 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 and eventually, the air runs out. That's where space begins. A place with no air to breathe and nothing for a plane's wings to push against. We need a rocket. What's a rocket anyway? Hello, science fans. Have you ever looked up at the moon or the stars and thought, wow, I'd love to go there? Well, getting there is a big, big job. You can't just take a car or a plane. The sky goes up, up, and eventually the air runs out. To make that incredible journey, we need a special kind of vehicle, a machine designed to travel where there's nothing to push on but itself. We need a rocket. It's not just a vehicle, it's a cosmic powerhouse built for the ultimate road trip. Think of it as a super strong, super sleek tube packed with power. Its main job is to push itself away from the Earth with so much force that it can escape our planet's pull and fly into the vast emptiness of space. Unlike a jet engine, which needs to suck in air from the atmosphere to burn its fuel, a rocket carries everything it needs with it. It brings its own fuel and its own oxidizer, the stuff that lets the fuel burn. This self-contained design is the key. Now, how does a rocket actually move? It's not magic, it's science. And the science is all about a brilliant idea from a very smart person named Sir Isaac Newton. He came up with 3 laws of motion, and the third one is the secret sauce for all rockets. Newton's third law says, for every action there is an equal and opposite reaction. It sounds a little fancy, but the idea is super simple. If you push on something, that something pushes back on you with the exact same amount of force. Imagine you're standing on a skateboard and you push against a wall. What happens? The wall doesn't move, it's very big and heavy, but you and your skateboard roll backward. You pushed on the wall, that's the action, and the wall pushed back on you, that's the reaction, sending you on your way. The rocket does the exact same thing, but instead of pushing against a solid wall, it pushes against its own fuel. It's a very clever way to move without needing anything external to push on, which is perfect for the emptiness of space. You don't need to build a rocket in your backyard to see Newton's third law in action. It's happening all around you, all the time. You are an expert in action-reaction physics, and you may not even know it. Think about blowing up a balloon. You fill it with air, pinch the end, and then you let it go. The balloon zips and zooms all over the room. Why? The air rushes out of the opening. That's the action. And this pushes the balloon in the opposite direction. That's the reaction.